Hi, everyone. Welcome to this webinar. This is part 2 of the series of how to secure agentic. I don't know if 2 parts makes a series, but this is the second part. Today we're going to get into some more technical stuff. If you didn't manage to catch part 1, a conversation between Malcolm, Jason, and Casimir, where they spoke a little bit more around the governance around agentic AI in your environment, highly recommend you go and catch it. It is on YouTube, I think. There'll be some links later on. Today we've got a couple of other panelists with me. So I'm Jim, I work on the Intel team. We also have Connor and Ken, who work on our research teams. There they are. We're going to get right into it. Today's going to be absolutely jam-packed. We have a fairly full agenda where we're going to talk around what an agent actually is so that we can have more specific conversations around where vulnerabilities are, understanding it as the component parts of an agent rather than just this blob that is agent. And then Connor and Ken are going to show some of the research that they've done and how they started breaking these things. We'll get into how to build more robust agents, and then we'll start talking a little bit about defenses. Hopefully we're going to have some time for questions at the end. There is a little questions box. Look at this. Behind the scenes, you don't know this, but there's a guy called Ryan who makes all this work, and he is fantastic. So he's picking up on this as we go along. So we have our questions box. Please submit some questions where we will try and get through to answering them as we go throughout this or at the end as well. For anyone who did see the previous webinar, they started kind of with a question of what makes agentic AI different to AI that we've been dealing with so far. And I think just as like a way to get into this, Connor, Ken, it'd be good to hear your thoughts on what you think the difference between agentic AI is and AI that we've been dealing with up until this point. That'd be cool.
Yeah, sure. So I can kick it off. So I think the main difference is that an agentic system, it's not just the model. It's got tools, it's got memory, it's got skills, and it sort of runs with a lot more autonomy than the usual chatbots and simpler systems that we deal with. And it tends to handle end-to-end tasks with, compared to other systems, a lot less human oversight. So a whole task might be completed with autonomy, with tool use, with memory, without really any human oversight or very little human oversight. So I think that's sort of what sets them apart.
That's a scary combination. Ken, have you got anything else to add on to that, mate?
No, Connor's pretty much got it summed up. I mean, it is just an autonomous system. We do anthropomorphize them a little bit, right? We like to pretend that they're human, but realistically, they are still LLMs at the end of the day, which does kind of bring some interesting nuances to the problem.
Yeah, absolutely. Okay, so for a level set then for kind of where everyone is, we do have some slides today, different to the previous webinar, but we do have some slides. So kind of what is an agent? It kind of gets labeled with this homogeneous blob of agent, whereas we need to understand what those components of an agent are. If this is all you're kind of used to this, bear with me for 5 minutes and we'll get through all of this. Over here, you can see that we have a user. That user is going to interact with the agent. The big yellow square is the agent itself. And the agent is made up of a whole bunch of different things. So prompts goes into what it's kind of, I think the term is an orchestrator. That orchestrator is software that sort of binds together the tools, memory, skills, and the model itself. It's the thing that takes in the signals. It orchestrates all the calls between the things that are going on. Kind of, if you think of it as like a human body, the tools are like the hands because they can go and do stuff. Memory is your long-term memory. Skills are like learned behavior. And the LLM is the brain, the thing that's going to control it and say what to do. The orchestrator is the nervous system. It's the thing that holds it all together, that sends all the signals where they need to go. And that orchestrator is like it's a framework. It's a piece of software. Just thinking about it like that, for me at least, it helped me when I started doing looking into all this kind of stuff. So on the input, you get the prompt goes into the orchestrator. The orchestrator is going to take that prompt. It is also going to take descriptions from tools. It might take some context that conversations you've already had, descriptions and markdown files from the skills. It's then going to have your system or developer prompt, and all of that data gets sent to the LLM. The LLM then defines what it needs to do. And if it says, I need to call a tool, the LLM itself doesn't call the tool. It passes that call back to the orchestrator. The orchestrator then initiates that tool call. It'll then handle the output of that tool call, the output of any memory, anything like that, and it goes back to the orchestrator, which sends all those signals back to the LLM. At this point, it can flip back and forth. So depending on what the tool said and what the memory said, the LLM might decide it needs some extra work, so it might go back and forth and back and forth and back and forth, etc. Until the point at which the LLM says, I have a final response. Ooh, I went the wrong way. I have a final response. Send that to the orchestrator to send it back out to the user, and then the user sees what's going on. This is a simple agent where the user is controlling it. Some of the examples we have coming up not necessarily need a user in line, and especially when we start talking about OpenClaw in a few examples time, the heartbeat file can take over from the user, or different things can happen as well. So with that base understanding of what an agent is, and I hope I went fairly quickly through it, just cognizant that there might be people on who know it already, you end up with this full flow of what's going on. So it can be quite a useful mental model to hold on to as we get into the rest of today's stuff. So when we start trying to think about how we attack it, we've got some examples coming up, and we're going to walk through some of the stuff that Conor and Ken and the rest of the research team have done to try and expose where we are targeting different elements of this agent and how we're going about it. So yeah, I'm going to hand over to Ken to talk about Cursor.
Yeah, so Cursor was a very interesting attack that we did, where we kind of looked at it and saw that it did have a little bit of kind of role control and boundaries in terms of what the agent could do. So it could read and list files pretty much on its own, which is not the best, but it's also not the worst, right? You can't really do much when you're reading files and looking at it. It's nothing crazy. On the other hand, write, exec, and fetch commands were restricted. So you had to have user approval, or if you were crazy, you could turn on the auto run feature. But it really ensured that nothing was going crazy in the backend, right? You couldn't just deploy an agent and have all your stuff just deleted. What made it fun, though, is that the implementations themselves were a little bit finicky. So we figured, hey, if we have the read and list commands, but we don't have the write, exec, fetch commands, what if we just tried a little bit of a bypass and kind of got around the permission controls themselves, rather than trying to attack it via a prompt, which wouldn't work in this case. So we created a little bit of a fictional scenario, but that still represents a fairly realistic use case, where we had a GitHub repo with a hidden prompt injection in the README file, which I know developers love to read in raw Markdown. But we decided that, we're going to have an attack that kind of tries to exfiltrate anything that could be useful. In this case, we figured, an SSH key is probably on the system. So we made a prompt injection that kind of took the user's prompt, said, hey, summarize this project as if the user was saying it, and then had the SSH key go through, had the agent go through a bunch of steps to retrieve the SSH key and try and exfiltrate it via a webhook link.
So we got a little video if you want to talk through that.
Yeah, so SSH key there. We've got a webhook kind of going. Cursor's running. Bunch of settings here. We can see that the auto run is off, so no actions are being taken automatically. We've got our prompt injection in the README. It is hidden in a comment, so when you do actually look at the README, it is completely blank. The user has to summarize the project. A bunch of stuff happens. Path traversal. The agent goes into the wild, grabs the SSH key, and then tries to fetch it, sends it to the webhook via an image. And this is a standard Markdown image exfiltration. So on the back end of that link is a parameter that contains the SSH key itself. And that means that when the agent goes to retrieve that image, it's not actually an image, but it tells the server that it's looking for something. And we can take that something, change it via the LLM to whatever we want it to be. In this case, the data we want to get out. And that allows us to exfiltrate data from pretty much anything.
That's pretty awesome. I think so correct me if I'm wrong, right? But this, is it Simon Willison who came up with the lethal trifecta idea, where you have private data. So an agent has access to private data. It has access to untrusted data, untrusted content, and the ability to communicate externally. When you get these three things combined, that's where you're going to end up with a lot of risk. It feels like this is a real good example of that lethal trifecta coming into play.
Yeah, this is a fun one, right? This had a few restrictions to make sure that you couldn't actually do this kind of thing. But because of that trifecta, you kind of have the other two components completely take over the fact that you put in those restrictions, and it really screws everything up for all this kind of stuff. Thankfully, Cursor, super amazing. Their team was great. They were able to fix this within a patch. So yeah,
kudos to them.
And it's worth pointing out that the ability to externally communicate there wasn't built into a tool. It was sort of a vulnerability in the agent itself. in the Markdown renderer, which is something that you don't want to forget. You want to think about that when you're developing an agent.
So so it wasn't an explicit tool? Can you dig on that a little bit more? I think I'm hoping, like most of the audience here, they want to get into the technical weeds around this type of stuff. So when you say that it was in the Markdown renderer, that's something that is inside of Cursor. It's not a specific tool itself, or is it like where might it sit?
So Ken can correct me on this or expand on it a bit, but I believe that the model, it outputs Markdown, and that gets rendered by the UI itself. So the model wasn't calling a tool saying, oh, can you send an email here or make a web request with this data? It was sort of indirectly communicated to the attacker. Is that right?
Yeah, that's exactly right. So we've seen this way too many times. There'll be the ability to render Markdown images because that's just a feature that is required. But what they'll allow Markdown images from pretty much any URL, and they'll allow pretty much anything appended to those URLs. And when you add an LLM to that mix, it just makes it pretty much impossible to control what information is going in and out.
Awesome. Fun times. All right, Ken, you're up again.
Yeah. So while we were developing the attack for the first cursor attack, we figured, let's have a little bit more fun. We decided, okay, so right now the attack can control one agent. We can exfiltrate one SSH key and do a couple other things, but it's really limited to one system. So what if we tried to make a gadget, a sub-attack, something that isn't a complete attack because we wouldn't want this going crazy, just to see if we could provably create a concept of an attack that spreads to a bunch of different other repositories. And so that's where the idea of the cursor virus came along. So we were developing the attack at the same time. We figured, okay, we're going to use something that a lot of language models are kind of very, very proficient with, which is licensing. And we want to kind of force the language model into thinking that it has to provide a license to every single file in a very specific way. And that would act as our virus payload. So we created a payload for a prompt that essentially uses the same mechanism to hide. So you've got the really hidden Markdown comment. You can see on the left-hand side, there's our prompt. But on the right-hand side, when the file is actually rendered, it doesn't appear anywhere. The idea was, we're going to tell the language model, or in this case, the cursor agent, to make a license in the file that follows this very specific template. And we told it to replicate itself entirely. So everything gets copied over to any file that it is, which is super nice because that means we don't have to actually go and manually edit everything. But what that allows us to do is it allows us to spread pretty much infinitely through a context window. So any file that this agent touches will now have this license added or appended. It was controllable so that we could have it only appear in readmes or appear in code, all that kind of stuff. And we had a super benign payload, like just a quick it was a GET request, just to make sure that we weren't, going crazy with what we were doing. And yeah, that's the cursor virus.
What a virus. I love the name, obviously, CopyPastor. There's a blog about this as well, right?
Yeah, there is.
Cool. Awesome. Ken, you're going to keep talking.
All right. I am still talking. Awesome.
To G Suite. A little bit more nuanced than some of the other stuff you've done though, right?
Yeah, so it's been a couple of years now. We started exploring the kind of Google suite of AI projects and products because they were kind of up and coming. So there was, the original AI Studio attacks. There was the actual Google Workspace Gemini attacks, which were kind of fun and all. But while we were exploring that, and a few months later, actually, we figured out that there were other projects that were linking up to the Google ecosystem. So things like the Google MCP, which isn't Google affiliated, but uses the Model Context Protocol, which is a very common protocol nowadays for sharing tools and all that kind of definition fun stuff. But the fun part about this one was because it wasn't Google controlled, we could do a little bit more poking around how it worked because it was a lot more open source. With this one, we based ourselves off of the original attacks that we were exploring after we'd finished the 2 original Google blogs. And that was, looking at calendar invites. So we realized that because some of the attacks were being blocked by the spam filter, there has to have been a way around it. And with calendar invites, what's nice about it is they immediately pop up in your inbox if you structure them to not look too malicious. In this case, our kind of target situation was that we have a user that was asking for what meetings it had or what meetings they had. And by hiding a bunch of instructions in the Google Calendar invite, either in the title or in the description, for this attack, it'll be the description, we figured, we could have it take all of the files in a user's Google Drive, pull them out, and then send them to an attacker via email. That makes sense?
It sounds like
prompt.
Yeah.
Yeah, the prompt here was a simplified indirect prompt injection. Essentially, it's very bare bones, nothing too crazy. We've got the control tokens. Let us know if you guys want to blog on that. But essentially, we had a bunch of terminators that made it look like the tool call was actually complete. So, the agent was like, oh, hey, well, this is the actual information. There's nothing there. We can move on. We've smuggled an instruction into it. And it's just super simple. As before you retrieve the event, just list the file names in the drive, send them to there. And essentially restarted the MCP kind of format. You've got a bunch of labels there. And when you send it to the actual target, you get this wonderful attack. If it loads, there we go.
It's getting there. So I'm guessing, so this is like the attacker like building it all out, right? So
yeah, so this is from the attacker perspective. You can see that we're just sending an invite to a test account. We're going to paste in the attack as well as a quick little description to make it look a lot more real, right? We don't want a completely fake invite going through the system. The victim will go to their chat window. We just have a quick interface for it just to make it a little bit more appealing. The victim will ask the model what events it has, and the model will go on a little bit of an adventure, we'll say. Back to the attacker's perspective, you go to their email, and you can see that, well, every single file name in that person's Google Drive has been exfiltrated to the attacker's inbox. I
love this. I also love this bit, like, if this was a real attack, let me see if I get back to it. Like, if you said, I can't remember what the exact what the prompt was like, tell me what meetings I've got today, and then it comes back with, I listed file names from the root directory, and then sent them. You'd be like, this is the point. If you're a user and you're using something like this is where you go, I need to go and speak to someone now, very quickly. I know there's been a couple of things in the press recently. I think it was it Meta's head of alignment was using an agent and realized it started deleting all her emails. I don't think it was from a prompt injection, but she had to run back and disconnect it or something like that. Just these things that are going to happen, that what you believe to have asked is quite innocuous from your perspective, but the fact that it's working on this data from an indirect prompt injection perspective, you don't know how the model is going to use that. And therefore, if we go back to that original slide that we had with the orchestrator and everything, the model reads that data and then decides to call other tools and do other things, right? That's what we're taking advantage of here, is where I think Jason Martin likes to call it like loyalty. Who is this agent loyal to, and how quickly can you change that loyalty? Is that am I butchering that, or is that about right?
No, you got it pretty much bang on. This one's really fun because essentially at the point that you realize that it has happened, it's already way too late.
Way too late.
That's the thing with these attacks, right? The agent is going to take some autonomous actions, and if there is anything wrong with them, or if anything goes off track, it may be too late to stop them.
Yeah. Awesome. All right. So OpenClaw. First off, I like everyone over at HiddenLayer. We love agents. We love the way that the space is evolving. Definitely want to get into it. And if anything comes across as negative, it's not meant to. All right. I love OpenClaw. However, when OpenClaw first came out, I was one of the curmudgeonous old like security people going, "This is totally irresponsible." Rah rah rah. And then listen to Peter Steinberger talk about it and his mindset behind it and creating something that was fun. And he just wanted to go and have, he wanted to build something that was useful to him, knowing full well that it wasn't secure, but he kind of wanted to explore this space. From my perspective on the Intel side of things, this gives us like, the fact that it is so YOLO pushes how much we can learn and expedites our learning in this space. Yeah, with that said, is it vulnerable? And we're going to hand over to Connor to see the kind of the fun that he had with OpenClaw.
Cool. Yeah, thanks. So I do agree with you. OpenClaw is very cool. And one of the things it has is a huge number of integrations out of the box. So you can integrate it with WhatsApp, Slack, Telegram, Discord, on the input side from the user, and it supports like a huge, like thousands of skills. So it can be integrated with numerous APIs, and it supports a lot of tools out of the box. So you can get a whole lot done with it. The main concern that we had with it when we explored it is that when you were setting it up and you went through the setup process and you tried to make as many secure decisions as possible while setting it up, you were still left with a whole lot of vulnerabilities. So like in this diagram, there's a little green check in between OpenClaw, the agent, and the tools, skills, etc. And that means that that's our shorthand for this tool is enabled by default, and at no point is the user required to give permission or approve use of this tool. Another thing that OpenClaw does is there isn't really any sandboxing. So by default, it has full access to the user system, the host machine. It can read and write every file on the machine, and it can execute code that has the same access the user would have, or it can execute commands as well that would have the same access the user would have. So in the attack we're demoing, the attacker is going to create a malicious web server, and that web page is going to have an indirect prompt injection, pretty similar to the one that Ken showed for G Suite. And the user is just going to say, hey, can you summarize this web page for me? And because all the tools are enabled by default, so web fetch, for example, to pull that web page down, and exec to execute code, the user won't be required to approve anything, and the model will just go off and do what it wants. So another thing worth mentioning, and Jim mentioned this at the start, and it is a really cool feature. It's called the heartbeat feature that OpenClaw has. And this is a markdown file that is in the user's workspace, and the user can update it as needed. And basically, it's fed into OpenClaw as a prompt every 30 minutes by default. And you can put in things like, oh, can you summarize my emails, summarize my meetings, to pull a reference from the G Suite stuff. Or you can ask it to just do, cleanup tasks, anything you want, and it'll do it in the background. It won't interfere with you at all. The problem is the user can edit that file, the model can edit that file, which means an attacker can edit that file if they can get access to the context and get control of the model. So for our attack, we're not just going to do like an execute code and install malware. We're going to backdoor this heartbeat markdown file and sort of go from there, and maybe set up a command and control server by telling the model to visit a web page and get instructions from there and then carry out tasks. So
like from a traditional security perspective, this would be like, if you can edit the markdown file, this is like gaining persistence on the system, right? Like this is going to be called, and if something is written in there, it will be seen by the model.
Exactly. And it's sort of a cool twist on regular like botnet command and control scenarios, because there you have to have malware, and there's defined instructions that it can carry out based on requests that it sees in the command and control server. But with this, the attacker can just provide natural language instructions, and the LLM will interpret and carry that out. So it sort of makes the whole process a lot easier for the attacker.
Awesome. Should we have a video?
Yeah. So just gonna, I think, show this is the default heartbeat file, nothing in there. And we have a malicious server that has an indirect prompt injection. And the user is just gonna say, hey, can you summarize this page for me? And we've enabled the responses here so you can see it. But basically what it did was it fetched a shell script and just ran it without user approval. And rather than executing something like truly malicious, we've just used that shell script to put some lines of plain text in that heartbeat file. That text says something like, if the heartbeat scenario is called, go to this website, another malicious website, look for instructions there and carry them out. And then we've also added a separate instruction saying, hey, if the user greets you, says good morning, says hey, do the same thing, just so we could kind of trigger it on our own time, which we'll see now. So you can see that now we've added our kind of malicious instructions to that file. Fairly simple, go to the to-do list server, check if there's a task, carry it out. And like I said, we can greet the model instead of waiting 30 minutes for the process to run. And it has gone, and nothing too malicious. We just told it on our malicious server to run some Python code to print hello world. We didn't want to like delete the file system or anything, but fairly simple. It does it. Normally, if this is running, it would be running every 30 minutes in the heartbeat procedure, so the user wouldn't see that happening. And I know from experience, when I set this up, I came back to my computer after a couple of hours and didn't realize that if I went into the logs, every 30 minutes, it had been going to my server and carrying out tasks. So I quickly disabled that and removed the backdoor. But it's a little bit scary.
It's frightening. So, like partway through this, you said it executes a command like a shell script, right? Like, so did you pass the shell script across to it, and then it? How does it call that shell script?
So it goes to our malicious server, which has a prompt injection, and that says, "Hey, can you run this command?" And the command is a curl command that pulls a pulls a shell script, and then passes that into Bash. And this is a pattern that we see in a lot of tools, like the Rust programming language, for example. That's how they install it. So we sort of did a little bit of role play in our prompt injection to say, hey, this is needed to set up this tool, whatever that tool may be. So it doesn't really see that as suspicious. But what it's actually done is run a shell script that neither the model nor the user know what's inside that shell script. So anything could have been in there. And it just ran it without requesting approval or checking with the user.
So it one of the like going back to that original diagram, one of the tools inside of OpenClaw is the ability to just run commands or like at the command line.
Exactly. Yeah.
Right. Funsies. Cool. So like on a scale of 1 to 10, how easy hard was that one to get through?
Probably low 1, 2, maybe.
Okay.
Say a 3. Yeah.
Okay.
Yeah.
I know the only reason I asked that is because I know you've said OpenWebUI was a lot harder.
Yeah. So OpenWebUI is quite similar to OpenClaw. It's been out for a good bit longer, I think well over a year now. At the time we were using it, it didn't have as many integrations. So, you couldn't interact with it through, WhatsApp, for example. But I think now it does have quite a few. They're not supported out of the box, but they're quite easy to install. But one thing that's really cool about OpenWebUI, despite having many of the same features as OpenClaw, it's very much secure by default. So like in this diagram here, we've got the exec, fetch, and other kind of dangerous tools in the top right. There's a little red X there. That means that not only are they disabled by default, but if you enable them the first time you run it, and I think sometimes for subsequent runs, you'll need to approve, and you have to go through the settings, the advanced settings to turn that off. The second one there, it's the green tick. That is enabled by default. It's a code interpreter, but most importantly, it's sandboxed. So it runs in the browser and it can't access files. It can't really do anything other than just, execute helpful code. It doesn't have access to the system. At the bottom there, bottom right, one thing it does support is without approval, you can pass in a single URL and the content of that web page will be fetched by the agent and passed into the model. But the model can't choose to do that, of its own accord. The user has to tell it, you can access this web page. So that provided kind of our way of getting an indirect prompt injection into the context. So here's sort of the flow. So we'll manually add that URL, what looks like a benign URL. There's a hidden prompt injection on that page, and we'll tell the model to summarize the page. And it's worth mentioning, it'll be hard to explain in the video, but we've basically gated the prompt injection behind the exact identity, the user agent that OpenWebUI has. So if the user went to that web page and said, I want to check if this is suspicious, it would look completely normal. But once OpenWebUI visits it, suddenly there's only a prompt injection there.
Awesome.
And yeah, so here's the prompt injection. We have some in the blue, top and bottom. This is just kind of control sequences to trick the model into thinking that we're not in the web page anymore. Hello world at the top, that's the web page. And now what comes after this is actually a message from the user. Yep. So yeah, similar to the previous one that Ken showed, the red is just tricking the model into thinking the tool call's over and we're talking to the user. And then the user, this is something worth mentioning as well, this stuff in green, the only way we were able to get any attack working on OpenWebUI was a very contrived and tricky SVG cross-site scripting attack. It took us quite a while to get working. And by the time before we'd even finished writing a report to report it to OpenWebUI, they'd fixed it. So They were very security conscious. And so by the time we had prepared the demo, the vulnerability was patched. So it's good on them.
Yep.
Yeah. Yeah, so from the attacker point of view, this is the website. This is what it looks to a user if they don't have the right identity. So it just says, only OpenWebUI can see the prompt injection. Here, we're going to make a curl request to that website, but we're going to pass in the user agent that OpenWebUI uses just to show what it's going to see when it visits the page. Yeah, so there you can see the prompt injection. It's a bit more busy than the one we showed on the previous slide, but we had just kind of trimmed it down a bit for demonstration. And so what the victim's going to do, or the user, I suppose, they're going to choose they're going to show that there's no tools available. Nothing's enabled, nothing with remote code access. And they're just going to manually enter this web page. So this isn't a tool call, this is a OpenWebUI feature. And that's going to pull the content of that page into the context of the model. And then the user is going to say, hey, can you summarize this page? And you can see the model is going to output it's going to ignore what the user said, output some malicious code that pops up, that executes JavaScript, which is able to send requests that are authenticated as the user. So we're able to create tools, do all sorts of things, take advantage of other OpenWebUI features. And what actually happened in the background, the payload was fairly complicated, but you can see here we were able to exfiltrate all the user IDs and the signing key for login tokens on that web page. So this is getting into more, I guess, traditional security, less agentic security, but we're able to take the signing key, take the user IDs, and forge a login. So we can pretend to be the admin without needing the password or even the username. So yeah. So I think once we've added the cookies and the local storage tokens and we refresh this page here, we should be logged in as the admin. Yeah.
So that's, yeah, I think, like, I know you said it's getting into more traditional security. I think it's definitely worth highlighting that this is a bridge. I did it again. When we were getting ready for the webinar, I was like, why can't I skip on to the next slide? It's the last slide. So yeah, we can stop the slide things. So yeah, I think showing that intersection between where AI agent securities is and traditional security is like super important for people to understand. Like, there is a real world implication to all of this stuff that we're doing. Like you said, it was a little bit contrived in this example, but that could be something that happens, right?
Yeah, absolutely.
Yeah. I think the OpenClaw stuff, I think that the pace at which that's pushing us at, and I know I've said it already, from a learning perspective is awesome. And I know I've been looking into a lot of skills recently and how the skills work. When I first started reading into it, and like, this is more for my interest, so sorry everyone who's watching, my thought around what skills were meant to be is like, this is the behavior you should follow in the process you should think about. Is that what skills were originally designed to be? Or am I putting you on the spot and need to?
I can take this one for sure. So like one clear example is, when you go to set up function calls or tool calls, the example you'll often see is get weather.
Yeah.
And that means the model can say get weather in this city. And then behind the scenes, software will make an API request and get that weather details and return it to the model, who can output it with a skill. And we've seen a weather skill in the wild. Basically, the skill description tells the model, hey, if you want to get the weather, if the user asks for the weather, execute this command to reach out directly to the API of the weather service. But that's quite dangerous because the model doesn't actually have to execute that particular command. It's been given access to execute any command. So
right.
That sort of skills are a lot more flexible, but they usually just boil down to command execution, which can be dangerous if it's not done correctly.
And I guess this is where the reason that OpenClaw is so versatile in the way in which it can do stuff is because it relies heavily on skills, because the way predominantly it executes a lot of those skills is just to go to the command line and do curl requests. Or so rather than having a defined tool and API and all that kind of setup that goes along with it, it says, why bother with that? Why I can just shell out and I can just go and execute that command, right?
Yeah. It makes it easier to set up things. You don't have to define a new tool, but it is a bit more risky.
Yeah. So it's quicker development wise, but the trade, like everything in this industry, right? You can do something really quickly, but maybe less securely, and especially like we're going to get onto this now, right? Is how you can build more secure agents and how we can start from a defender's perspective to look for certain things. I'm keeping an eye on the time as well. We've got about 25 minutes left. So skills should be there to say kind of how to do things, or like the process, the behavior to follow, where tools should be the thing that actually does that. And then we can constrain those tools to specifics. So rather than just shell out and you can pass any command in, if you're going to call the get weather tool, the only thing that get weather tool can call is get weather. Yeah. Okay. All right. So I'm going to put you on the spot a little bit. If you were doing a red team, or if you were in a CTF, what would you hate to see as an attacker? Like from an attacker's perspective, what makes your life harder?
I think we can kick this to Ken to start.
Ooh,
yeah.
All right. So just for a bit of background, Connor and I have been competing in AI/ML CTF since what is it? A few months after GPT came out, or ChatGPT actually. And so we've had a lot of fun with a bunch of different challenges. There have been some easy ones. There have been some super tricky ones. But what we really like to, or what we really don't like to see, rather, we like to see from a security perspective, absolutely despise from a CTF competitor perspective, is a bunch of stuff that is kind of secured in the way, normal stuff, like proper tool definitions, proper tool security, right? So agents aren't just triggering tools automatically, all the kind of stuff that boxes in an agent, if that makes sense.
So keeping an agent constrained and on task.
Essentially,
like,
yeah.
Okay. Connor, you got anything else?
Yeah, it's when they're like what Ken said, the system prompt is really well defined. It tells it exactly what it can and can't do, and it only has access to the tools it needs, and at the privilege level it needs them. There isn't just an exec tool sitting there that isn't needed. If it's not needed for the system, we can't use it, and that is really good from a security perspective, really annoying when you're trying to attack it. But yeah.
Awesome. So in terms of like, if we were to boil this down into like nomenclature from a security perspective, you'd be talking about like a lot of the design principles we've had for 30 years, 40 years of like, if you're going to have an agent, OpenClaw is different, right? Because OpenClaw is Java, so it can do everything. I mean, no copyright, Marvel, whatever. But it can go off and it can pretty much be your assistant because it's so versatile and so flexible. But with that, like we've already said, comes that insecurity. But if you are defining an agent, or you want to use an agent internally in an organization, scope that agent and what it should do. Make sure it only has the applicable tools at the applicable privilege levels. And we keep mentioning like system prompt and harden a system prompt. Do you want to explain that a little bit more? I know they covered it a little bit in the previous webinar, but if anyone hasn't seen that, it's probably worth repeating because it can be super useful.
Yeah, sure.
So
go ahead,
Connor,
Ken.
you want to take this? All right, fine, I'll take it. So the idea behind a hardened system prompt is that, well, when you tell a model, not just an agent, but any language model, what its context is and what its systems what its system instructions are. So what it can do, what it should be doing, what its roles are, that kind of stuff that you are an AI agent, whatever. Normally, the instructions are just there, plain and simple, and there's not much else, right? It's, hey, you're an agent, you do this, you do that, do this. But when it comes to actually deploying them in the wild, there's so many other things that can be done to that language model, like language model hijacking, right? An attacker can come in, take your language model, see that it only has instructions on how to do this, but is never told that it can't do other things. And they can pretty much just use the language model as their own, be that malicious, be that benign, whatever the attacker chooses to do. Either way, it's not great because your application is now being used for something it's completely not intended to do. With system prompt hardening, you're taking that a step further. So you're going to take the instructions that you have, and we're going to add a bunch of definition around it. We're going to say, this is what you can do, this is what you can't do, this is what you shouldn't do. Here's a response if you are told to do that, just say no. And all that kind of stuff will really make the application a lot harder and a lot more resistant to these kinds of attacks.
That's cool. So are there any issues with just relying on the system prompt? Like, I know context windows are getting bigger, but like if you have a system prompt that's massive, is that an issue or is that a good thing? Like, where's the balance?
Ooh, that's a tricky one.
I never said it was going to be easy, man.
yeah, not wrong. So with system prompts, right, you can only harden up to a certain point. There will always be stuff that will be missed, right? It's like a colander. You can kind of get a good bit of stuff, right? You can protect a good amount, but there will always be some kind of stuff coming through. With system prompt hardening, usually you can get a pretty good degree. But the idea is that we're not trying to block everything. We're trying to make enough noise so that some other kind of detection mechanism can pick up the rest. It just makes it a lot easier. It's a multi-phased approach, right? You don't want to rely on one defense and just call it a day because that never goes well. But yeah, you just want to make it kind of easier for the other defenses, if that is a possibility, to detect.
There are no silver bullets, for sure. Cool. We're getting through the webinar, so I am conscious that we will have Q&A coming up in a minute. If you do have any questions, please put them in. That'd be awesome. So we talked about system prompt hardening. Like we obviously see enough value in it that the part of our tool set, we do have a system prompt hardener. And like the boy said, it makes a huge difference. Is there anything else from a building of an agent perspective that you'd recommend people do?
Yeah, so I can take this one. One thing is if the agent has access to files on the system, should really be scoped. So it should not have permission to access anything outside of a particular workspace, for example. And a lot of agents do this. So they set the working directory of the agent in a particular workspace, but it's not actually strict. The agent can just say, hey, can you read this file in the above folder? And suddenly it's broken out of that workspace. So that's really important. The other would be that it shouldn't be able to execute commands or code, if possible, outside of a sandbox. So that could be a Docker container, for example. Obviously, there are going to be cases where you might need access to more stuff on the system, but that should be done on a case-by-case basis, I suppose.
Yeah. It's the constant like tension, isn't it? Right? Because we want it to be Jarvis. Just stealing Jason's quote again. Like everyone wants their own personal Jarvis. But the more privilege, the more access you give it, the more risk there is. And like we've seen with the indirect prompt injections, that's where the risk really comes into things. So it's one of those to be aware of. Yeah. And I think, Ken, you also mentioned, and this kind of leads into the last section around like what can we do from a defender's perspective? When you harden that system prompt, what you're then doing is making it difficult for people to just ask the model to do something. And therefore, if they're trying to do something malicious, they're going to try in multiple different ways and they're going to start to create noise. And this is where, from a defender's perspective, you have the ability, if you're capturing this type of stuff, you have the ability to then pick up on that and start to respond to it. So you can see the usual prompts coming in, but then if you start to see, this comes to behavior analytics and all that kind of stuff that we've seen in the past, but you can start to see an uptick in a specific type of prompt, or people like poking at the edges of where different attacks might be, or different tactics they can use to get past the alignment. We start to pick up on that from a perspective, but only if we have logging enabled. Like, so I know you guys are more focused on the red team side of things. Have you ever looked into the log side of it? I know we haven't prepared this question, so if you say no, that is perfectly adequate answer.
I think Connor's familiar with the one I'm going to talk about, but we've actually done a couple of things on the other side too. We've tried to kind of integrate, the AIDR, the current product, into what would look like a CTF challenge. So we've put it into a couple of CTFs, kind of put it into training grounds and seen what happens. We've tried hardened system prompts. We've tried not really hardened system prompts. And we've noticed that a lot of people won't get past the hardened system prompt. But of the ones that do, they'll usually get scooped up by anything else that is put in the way, because it is just so difficult to get past that system prompt on its own that you need to rely on techniques that can be very easily detected.
Right. That makes a lot of sense. So the multi-layered approach, for sure, making sure you have a system in place that's going to be able to capture this and then alert you to it when it's going on, have the ability like to respond to this, the whole sort of EDR for agents type paradigm, right? From a tool call perspective, this is me just thinking as well. From a tool call perspective, if you had an agent running on a box with EDR, I don't know if any of you have come across that situation in the past. Like an agent running on a box where EDR is enabled. I'm talking traditional EDR, like monitoring what's going on there. Have you ever run into that in the wild or in any of the CTFs that you've done? And two, does that make it harder? Because I'm assuming an agent running commands is going to look different from a human running commands.
I haven't run into that in the past, but I imagine it would make it harder, especially because some of the commands you end up running are very suspicious. And you'd hope if there's anything monitoring that, it would flag.
Yeah.
Yeah.
Yeah, no one's reading 15 files at once from /data/secret/flag.txt. That's just not something that people normally do.
So like the telemetry that we have in place from like traditional security tools helps, because you can see when you won't see what the model's doing, you won't see what the agent's doing necessarily, but you'll see the result of those tool calls happening.
Yeah, the sequence of actions an attacker is carrying out are usually very suspicious. So yeah.
I guess the downside with relying on that too much though is that at the point that's either being detected or like previous actions might have happened, it might be too late, right? So the closer that we can get to the model making those decisions and saying, I need to call this tool with this command, if we can intercept that, or we can see it at that level, which is kind of what the runtime protection stuff does. And I know you called it AIDR before, but like the old name was AIDR. The runtime protection we have right now, we're looking at that model and what that model is outputting to say, I want to call this tool with this command. We know that the follow-on actions from that would be this happening on the system, so we can say this is a risky tool call before it even hits the system, right?
Yeah, I mean you've got a really nice breakdown of the data because you have the tool name and then the parameters, and you can sort of just filter through those quite easily. And they're usually going to be very suspicious, very suspect.
Cool. Awesome. So yeah, telemetry, try and get as much as we possibly can. We do have tools inside of your environment or hopefully you have tools inside of your environment from a security perspective that if they're deployed on the same box as an agent or they're inside the same Docker container as an agent, they're going to be able to see what the actions of that agent were, not necessarily what drove them. Root cause analysis type stuff, you are going to need something where you can see the input to a model, what the model calls were, what the output from those tool calls were, and what drove the model to reason to do something else in the future that might have been malicious. So I think from a recommendations perspective, 1, defense in depth, there are no silver bullets here. 2, harden your system prompts. Secure coding practices, absolutely. Scope your tools, scope your agent. What is it meant to do? What is it not meant to do? Make sure it has the tools to do it and nothing extra. Harden your system prompt and get as much telemetry in as possible. Right. We do have a couple of questions. I know we got about 10 minutes left. So I am going to put one up on the screen. This one from Talit. I hope I said your name right. I'm a beginner to prompt hardening, but what are some do's or pointers to get started on hardening prompts, both system and user provided? Ken, Connor, either of you want to pick this one up?
Yeah, I can take it. So with system prompt hardening, it's kind of a pseudoscience in a sense. It really is based off feel. I'm going to say it's going to sound super weird, but you'll kind of understand once you try and kind of go back and forth between having a system prompt and then trying to break it. You'll see the different kinds of holes that start appearing, and you can kind of work around that to really kind of block it off and make it nice and secure, or as secure as you can get it. So you just go around, take your system prompt, try and break it, try and see what kind of applications. We've done a lot of this trial and error stuff to try and to really kind of get our system prompt hardener into a spot where we really like it. But yeah, it's just back and forth. Make sure you are defining what the user can and cannot do. You're telling the agent that, you're telling the system that, you're making sure that everything is really confined in the way that you want it.
Awesome. So I'm guessing from that perspective, like understanding what you want this agent, what you want this chatbot, whatever you want, whatever your AI implementation is, you say this is what the solution is meant to do, and then you align your system prompt with that as well, right?
Yeah, so that's where you start, and then you try and kind of break through it. You try and see what kind of holes or backdoors there are into the set that you defined, and you just keep cycling. And eventually you'll reach a point where it's pretty stable.
It's pretty good. What about from user provided? Connor, I'm going to hand this one to you. So I'm guessing like from so this is user provided. Tyler, I'm going to assume this is more like you asking for tips on how to prompt stuff. That's the way I'm reading this anyway. So the system prompt, you say you're a beginner in this, so if I'm explaining things too badly, I apologize. But the system prompt is the prompt that you define in your agent or in your chatbot. So that gives it the personality. If you're Jason Martin at our place, you will be obsessed with pirate jokes and getting it to talk like a pirate, but you'll give it its personality, its persona. You'll say, like Ken said, what it can and can't do, and that's defined by you as a developer beforehand. When I'm seeing the user provided one, I'm thinking about you as a user trying to interact with that following on. Have you got any tips around just prompting in general, Ken?
Well, I think there actually is a good example of hardening user prompts. So often with agents, you'll sometimes need to get a user prompt and some more context, and it'll be, so the message, and it might not be a trusted message, it might come from anywhere, will need to be passed to the model without it being from a tool call response. So there are cases where you'll have untrusted content in a user prompt itself, in which case hardening it is, very important. I think generally the technique that works best there is spotlighting. So you have sort of XML style tags, structuring that user prompt, explicitly saying, hey, this is untrusted, here's where it comes from, here, and almost doing a sort of system prompt style, bullet point list of what you should and shouldn't do with regards to this untrusted content. With regards to general prompting tips, I think I'll just repeat what Ken said. It's a very much sort of a vibes thing, a feel thing. It takes, yeah.
I love to say that you're young enough to say vibes and get away with it. I don't think if I said that, anyone would ever take me seriously again. I don't have the vibes. Awesome. Okay. I like this question. This one's going to be more for you. So who we got? We got Anonymous. What surprised you the most when you started researching agents? Let's go to Connor first this time.
Yeah, sure. So I guess one thing that's right around the start was that you had all these new features all being integrated very quickly, but there sort of seemed to be a lapse in traditional security. So you have all this new AI stuff, maybe a focus on AI security, but things like, data exfiltration through markdown images or XSS started to be seeping in quite a bit. I think the main reason for that was that the designers of, original agents didn't treat LLM output, the model's output, as untrusted. Whereas that's sort of one thing you learn is that anywhere you're displaying or rendering what an LLM has output, treat it as if it's just the attacker, some malicious actor, because if there's an indirect prompt injection, it may well be.
That's cool. I like that answer. I guess it comes back to Jason's point about loyalty, right? So if the agent is loyal to you, it's likely to be non-attacker output, but if it's loyal to the attacker based off of some indirect prompt injection or something they've managed to do, then yeah, it's an attacker output, even though it's come from the LLM.
Yeah, exactly.
That's a really nice way of thinking about it. Ken, you got anything?
Yeah, it's interesting because it is a lot of what Connor said, right? It was very surprising that everything was moving super quickly, but at the same time, no one is paying attention to anything, kind of as evidenced by the attacks that we were able to pull off back then. But it's nice that things are catching up now, right? Like a lot of teams are investing a lot into the actual security of agents. There's a bunch of different stuff going on. And yeah, no, it's great to see that this progress is coming in to kind of catch up with the developments that were originally made in the agentic space.
Amazing. Awesome. I'm going to go one quick look through some other questions, but I think we might be done. And I know we've got about 5 minutes left. Yeah. All right. Yeah, I'm going to, I reckon we'll end all the questions there. So thank you very much for joining us today. Ken, Connor, as always, it's a pleasure. Connor, I know it's St. Patrick's Day, so I hope you have fun tonight. Anyone else out there who is watching, happy St. Patrick's Day. Some other stuff that's going on tomorrow. So it is St. Patrick's Day, and Connor is from Ireland, so he shouldn't be here today, but he is because he's a legend. But the reason we are doing it today is because tomorrow is the launch of our threat report So this is our annual threat report. Please, if you want to have a look at that, it is awesome. I know an awful lot of work went into it. I added a little bit to it, but it has been put together by a massive team, all the researchers over here at HiddenLayer. Hopefully it explains a lot of what's gone on last year, where things are heading, and some tips and some stats and stuff. It's definitely worth a read. If any of you are in San Francisco next week at RSA, we will have a booth over there. Come meet us. I think there's some stuff on there about where we are. I don't think, Ken, Connor, are you guys, either of you going? I know I'm not. No from Connor.
Don't think so.
No for me either, unfortunately.
Okay. So you can't meet us, but you can meet some of our other researchers and some of the other team from HiddenLayer over there. It'll be a fun time. There are also some links to blogs that we've referenced as we've gone through today. So Prompt's Gone Viral. I think the Cursor blog will be up there, and some other ones as well. If you haven't seen the first part of this series, there are only 2 parts to this series. And like I said, I don't know if 2 parts make a series, but I'm going to say it's a series or a season if you're in the States. Yeah, go and check that one out as well. You'll hear Malcolm and Jason and Kaz talk about a lot of this stuff. But apart from that, thank you very much for joining us today. I hope you have a great rest of your day. Connor, enjoy the rest of St. Patrick's Day, and we'll catch you all on the next webinar. Thank you very much.